Hi everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. S.N.S. Rajalakshmi College of Arts and Science. Today, in this series, we are going to discuss about computer networks and data communication. Today, we are going to discuss about a communication model, data communication. First, we see the introduction to data communication. So today we will delve into the exciting world of data communication, the foundation of modern communication systems. We will explore how data is exchanged digitally between devices, enabling everything from simple emails to complex video conferencing and global business operations. By the end of this presentation, you will gain a clear understanding of how data communication works and its significance in our interconnected world. So, next we see the data communication. So it's the process of transmitting digital information between devices. This information can be anything that can be represented in a digital format, such as text document, images, audio recordings, video clips, and even complex data sets. So the device involved in data communication can be anything from personal computers and smartphones to printers, servers, and various industrial control systems. Next, we see the why the data communication is very important. So, data communication plays a vital role in our modern world. It allows for real-time collaboration, enabling teams located worldwide to work together seamlessly on projects, share documents and ideas instantly. So, it facilitates efficient information sharing, making it easier for employees to access and exchange critical data, fostering better decision making and improve workflow. So the data communication allows underpins efficient business operations in every sector, from managing supply chains and inventory to providing exceptional customer services. Ultimately, data communication connect people and device across the globe, fostering communication and collaboration on an unprecedented scale. Next, we see the a basic communication model. In basic communication model, we are going to see about source, transmitters, channel, receivers, and destinations. So the source, this is the originator of the data, such as a computer, smartphone, or sensors. So it generates the information that needs to be transmitted. Next one is a transmitter. So the transmitter takes the data from the source and converts it into a signal that can be transmitted over a communication channel. This signal can be electrical pulses for wired connection or radio waves for wireless transmission. Modems are a common example for transmitters. Next one is a channel. Channel is the medium through which the signal travels from the transmitter to the receiver. It can be a physical cable like an Ethernet cable or a fiber optical cable or a wireless medium like Wi-Fi or Bluetooth receiver. So the receiver receives the transmitted signal and converts it back into its original data format. It essentially performs the opposite functions of the transmitted designation. This is the final recipient of the data. It can be another computer, a printer, a display screen, or any other device capable for processing the received data. Next, we see the types of communications channels. So, types of communication channels divided into two types. One is a wired communication channels, and another one is a wireless communications channels. We will see one by one. First one is a wired communication channel. So, twisted pair cable. It's a commonly used for Ethernet connections. Next one is a coaxial cable, used for cable TV and other older internet connections. Next, we see the fiber optic cable. Offers high bandwidth and low signal loss, ideal for long distances wireless channels. Radio waves, used for Wi-Fi, Bluetooth, cellular networks and satellites. Next, we see the data modes transmissions. So, in data modes transmission modes, define the direction of data flow between devices on a communication channel. So here there are three types of main modes we are using. First one is a simplex, half duplex and full duplex. First we see the simplex. This is the one-way communication mode. Data flows only in one direction. A common example in a simplex mode is a radio broadcast. Here a radio station transmits a signal to a large number of receivers but does not receive any data back. So half duplex, this is a two-way communication mode, but devices can only transmit or receive data at a time, not both. So both simultaneously. So think of walkie-talkie conversation. So users can take turns talking but cannot speak and listen at the same time. Next one is a full duplex. This is the most versatile mode. So allowing two-way communication to happen simultaneously. Devices can transmit and receive data at the same time. So a telephone conversation is a perfect example. Both parties can talk and listen at the same time, enabling a natural flow of conversation. Next one is network topologies. So in computer networks, we are using several topologies. Some of the common topologies are star, bus, mesh, ring. So network topology referred to the way devices are arranged on a network and how they communicate with each other. Here an overview of some common network topologies. First one is a star. This is a popular and efficient topology where all devices are connected to a central device. Typically a hub or switch. The central devices manages data flow and communication between devices. Next one is a bus. In a bus topology, all devices are connected to a single shared cable. Data packet travels along the cable and each device checks the destination addresses to see if the data is intended for them. This can be less efficient than a star network due to potential collision and bottlenecks. Next one is a mesh topology. A mesh network offers a more flexible structure. Devices connect directly to each other, creating a web-like structure. This provides redundancy and can be beneficial in situations where a central device failure shouldn't cripple the network. Next one is a ring topology. So in these devices are connected in a closed loop with data flowing in one direction. Each device acts as a repeater, regenerating the signal and passing it on the next device on the ring. While signal and passing it on the next device, so the topology can be less scalable as adding or removing device disrupts the flow of data. Next we see the what are the devices we are using for networks. So some of the devices are routers, switches, modems and firewalls. So routers is a they connect different networks and route data packets to their intended destination based on the IP addresses. So next one is a protocols. Protocols is a set of rules and regulations. So here the network protocols we are using the OSI reference model. So in OSI reference model we are using 7 layers. Some of the layers are physical layer, data link layer, transport layer, section layer and application layer. Next we see the data security in the communications. So data security is a protecting data from unauthorized access, use, disclosure, disruption, modification or distractions. So here we use the encryption, authentication, authorization and firewalls. So encryption, this process scrambles data using algorithm, making it unreadable to anyone who doesn't possess the description key. So encryption protect data in transmit and at rest. So the authentication, this ensures only authorized user and devices can access a network or resources. So next is the authorization. So this determines what actions authorized user can perform on a network or with specific resources. Permissions are assigned based on user roles and security policies. So in this topic we have discussed about the what are the protocols, what are the networks, what are the topology we are using. I hope you enjoyed this session. Thank you.